Here we have AP calculus BC problem. That is, we have to evaluate the limit. That is, limit extends to 0, cosine x negative 1 over x. Okay, so what we can do in the first step is we can directly substitute the given limit for x. That is, we have to plug in x is equal to 0 into the given function. Then I'll be getting cosecant 0 negative 1 over 0. Okay, so already we know that cosecant is a reciprocal trigonometric ratio of sine. So cosecant 0 can be written as 1 over sine 0. So we can get the value of sine 0 either from unit circle or trigonometric ratio table. So the value of sine 0 is 0. So 1 over 0 is undefined. So finally, the value of cosecant 0 is undefined, that is infinity. And we divide a finite value 1 or non-zero number 1 by 0. Whenever we divide a non-zero number by 0, so that will be infinity. So infinity. So when I directly substitute the given limit for x, I'm getting infinity negative infinity as a result. So actually infinity negative infinity is called indeterminate form. Okay, so I am getting when I evaluate the given limit by direct substitution of the value, that is in this case we have 0 for x. When I do direct substitution 0 for x into the given function, I am getting indeterminate form. Usually when we get indeterminate form as a result of limit, so immediately the students will feel to use the L'Hopital's rule. Actually, before we use L'Hopital rule, we have to consider the given function. It has to be in the form of f of x over g of x. That is, it has to be in the form of a fraction where both numerator and denominator must contain variable. But the given function cosecant x negative 1 over x is not exactly in this form. So our first work is to write the given function in this form f of x over g of x. Okay, let's do that one. Okay, here I'm going to rewrite the given function, that is limit extends to 0. To write the given function in the form of a fraction, so I'm going to use trigonometric ratio for reciprocal trigonometric identity for cosecant x. So cosecant x can be written as 1 over sin x negative 1 over x. Okay, so here we have to simplify the subtraction of two fractions. So here the denominators are not numerical values, so the denominators contain variables. So in this case, if I want to simplify the subtraction of two fractions, I have to do cross multiplication. That is, the numerator of the first fraction 1 has to be multiplied by the denominator of the second fraction, that is 1 times x is x. Limit extends to 0. So I multiply this 1 by this x and I'm getting x. Now, the denominator of the second fraction is multiplied by the numerator of the first fraction. 1 times sin x is sin x. Finally, I have to multiply the two denominators. That is, sin x times x will be x times sin x. Okay, here now I got the fraction in the form of f of x over g of x. Okay, now, anyways, so we have done some simplification in the given function. So we can apply the given limit that is 0 for x. When I do so, 0 negative sine 0 over 0 times sine 0. So 0 negative, the value of sine 0 is 0. So the value of sine 0 is 0. 0 times anything will be again 0. So I get 0 over 0. Again, I get an indeterminate form. So I short to write ID of indeterminate form. Okay, so I'm getting indeterminate form. So I'm out to use L'Hopital's rule. So where I have to use L'Hopital's rule? So L'Hopital rule has to be used in the step which comes before the step where we have applied the limit. So this is the step I have applied the limit. So I have to use L'Hopital's rule in this step. So before using L'Hopital's rule, please make sure the given function has to be in the form of a fraction where both numerator and denominator must contain variable. So it is exactly in the form of f of x over g of x. So here we have variable x in numerator, we have variable x in denominator. So this is a step I've applied the limit. We just consider the step which comes right before where we have applied the limit. So we have to consider the previous step of this one. I mean this step here I'm going to use L'Hopital's rule. So L'Hopital's rule means I have to find the derivative of the numerator and denominator separately. Usually when we have a function where we find variable x in numerator and denominator, and if I want to find derivative of that one, I'll be using quotient rule. But when I'm using L'Hopital's rule, I'm not supposed to use quotient rule. I have to find the derivative of the numerator and denominator separately. Okay, now I'm going to apply L'Hopital's rule in this step. Let me continue this on the next page. Okay, so limit extends to 0. So I've already told you, so I'm going to use L'Hopital's rule in this step because in this step I've applied the limit. Okay, so if I apply L'Hopital's rule in this step, I have to find the derivative of this numerator with respect to x. So it will become 1, the derivative of sin x will become cosine x. So the derivative of 1 minus sin x is, the derivative of x minus sin x in numerator is 1 minus cosine x. And in denominator, we have x and sin x. Both of them are multiplied and both of them contain variable. So here we have to use product rule. Product rule can be used either in numerator and denominator, wherever it is required when you are using L'Hopital's rule. So product rule means you have to keep this x as it is, find the derivative of sin x. Then positive, find the derivative of x, keep the sin x as it is. So first I keep x as it is. The derivative of sin x is cosine x, positive. Then I find the derivative of x and I keep the sin x as it is. So after simplification, I'm getting sin limit extends to 0, 1 negative cosine x over x times cosine x positive sin x. Okay, that's all the simplification I can do. So now I can apply the limit 0 for x. So 1 negative cosine 0 over 0 times cosine 0 positive sin 0. So it's okay. Let me continue over here. 1 negative, the value of cosine 0 is 1, and here 0 times anything will be 0 positive, the value of sin 0 is 0. So 0 or 0, again I'm getting indeterminate form. Okay, since I'm getting indeterminate form, again I have to use L'Hopital's rule in the step which comes right before the step where I apply the limit. So this is the step I have applied the limit. So consider the previous step, this step, here I have to use L'Hopital's rule. Again, by using L'Hopital's rule. So that means I have to find the derivative of the numerator and denominator separately. So the derivative of this 1 is 0. The derivative of this, actually this negative sign should be taken as it is. The derivative of cosine x is negative sin x. And here I have to use the product rule. First I keep x as it is. When I find the derivative of cosine x, it will be negative sin x positive. I find the derivative of x, which is 1, and I take cosine x as it is positive. The derivative of sin x is cosine x. Limit extends to 0. Negative times negative will become positive sin x over x times negative sin x will be negative x times sin x, positive 1 times cosine x is cosine x, positive cosine x. Okay, let me continue on the next page. Limit extends to 0, and in numerator we have sin x, and in denominator we have x times sin x, and when I combine cosine x and cosine x, it will become 2 cosine x. Negative x times sin x, positive 2 cosine x. Okay, that's all the simplification we can do. Now we can substitute the given limit for x. That is, we have to plug in x is equal to 0. Then I'm getting sin 0 over negative 0 times sin 0, positive 2 times cosine 0. So the value of sin 0 is 0, and here 0 times anything will become 0, positive 2 times the value of cosine 0 is 1. So 0 divided by 0 plus 2 will be 2. I divide 0 by a finite non-zero number. So whenever I divide 0 by a non-zero number, the result is 0. So the evaluation of the given limit is 0.